This video is going to look at kinematics equations from the perspective of an object in free fall. So anytime that an object is only operating under the influence of gravity, we say it's in free fall. It can be thrown up, thrown down, or simply dropped, and or thrown sideways. Anytime that once it leaves your hand, um, the only force that's acting on it is gravity, if we assume that there's no air resistance for now. And it is in free fall, and they always follow a parabolic arc. So you can see here I have a very slight angle. It's going up at 88 degrees rather than 90, but you can still see that this is a parabola. And if we change the angle, all of the trajectories will be parabolas, some narrow, some wide, but they're all parabolic. So let's have a look at a problem here now. I have an initial speed. So my V0 is 17 meters per second. And the acceleration due to gravity, so this is up. My initial velocity is going to be straight up. And that means that my acceleration is going to be the acceleration due to gravity. And that's going to be down. So we had to call that negative because we've called the upward direction positive. And I want to know how high is it going to go. So I want to know, what is the x? So this is the distance to maximum height. How high will it rise? And I know that at maximum height, if we click in here, at maximum height, that's where it just comes to a stop for a second. And so it comes to a dead stop right here, and I can actually place this tool over and find out what the max height is, and it looks like it's 14.71 meters. So we know that at the max height, the v has dropped to 0. So now we're going to use the v squared equals v0 squared plus 2ad, and this is 0, and that's 17 squared plus 2 times negative 9.81 times your, I put in a d here, but it's supposed to be x. And the x is going to be minus 17 squared over 2 times negative 9.81. And the displacement will come out positive. So we have 17 squared divided by 2 times 9.81. And that's going to give me 17 squared divided by 2 times 9.81. And we get 14.7, which is what the simulation also gave us. So 14 points, and I'm just going to assume here that these are 3 digits. I know I can't change this on the screen, but I'd like to work in 3 digits, so I'm going to assume that everything is in 3 digits, and this would be 17.0 as well. So if you look at this, and there's 14.7 that conforms. So I want to find out how many seconds will it take to rise to the maximum height. That's the other thing I want. And I know that the answer is going to come out to be 1.73 seconds, or it should anyway. So here, I know that my V0 is 17 meters per second. My acceleration is minus 9.81 meters per second squared. My v, the final v, is 0. I want to find out what is the t, and now I can use the v is equal to v0 plus at. The v drops to 0, so the 17 plus negative 9.81 times t, and the t is going to be minus 17 over negative 9.81, which is what you would expect. So 17 divided by 9.81 is 1.73 according to this. And if I place this over, I get 1.73. So the two things match. That means that our simulation has been programmed correctly. And the other thing that was mentioned in class is that the speed at impact is 17 meters per second. So you've got a velocity of 17 meters per second up. And when it lands, It has the exact same speed, assuming that there's no air resistance and it's not losing any energy. We're back to the same level. The speed at impact should have like a different color here. I'm going to use black. So the speed at impact, or the velocity at impact, is going to be minus 17 meters per second. It's being launched at 17 meters per second. Here the v drops to 0. And then when it lands, it has a velocity of minus 17 meters per second, and everything is symmetrical. So let's move from that case to the one that's a little bit more complicated. I'm going to erase everything here. It's all preserved now. So I'm going to go over to this one that I already have set up. And now I'm launching from a 12-meter height, and with the same initial velocity of 17 meters per second straight up. And I want to know, number one, what is the V at impact? So let's get this going here now. So what is the V at impact? And how many seconds is it in the air? So these are some of the things I can address. So number one, and these problems are definitely more difficult when you have this going up and going down. So I have my initial velocity is going to be 17 meters per second. I'm not going to write in the third digit, but let's just assume it's there. I'm going to put the third digit in the answer. And I want to know, what is the V at impact? What is the V when it hits the ground down here? And I know that the displacement, the X, so if you look at this, if this is a number line, then everything on this side is going to be positive, and everything on this side is going to be negative. We've chosen the upward direction as positive, so that's going to set our signs. So now all of the displacements above our starting position are going to come out positive in our equation. But all of the displacements below our starting position are going to come out negative. If we were to plug all this into an equation, the equation would give us a negative. And here the acceleration is down, which would be minus 9.81 meters per second squared. So here's the things that we know. So we know that our V0 is 17. We know that our A is minus 9.81. We know that our displacement, and this is a key point, is minus 12 because it is below our starting position. And we're looking for, what is the final V? And so we have our V squared equals V0 squared plus 2AX again. The V squared is the unknown. So this is your V squared, 17 squared plus 2, negative 9.81 times minus 12. And this is going to give us a positive number. And you might remember this from class. Plus 2 times 9.81 times 12. It's going to give us the 524, and I believe that's the same example I did in class. And so that means that the V is going to be the square root of 524. Now, I've already told you that here, this has got to be negative. The final answer here, our final velocity, has got to come out negative because our initial velocity was positive and our final velocity is going down. So when you take the square root of 524, you get plus or minus 22.9 meters per second. But we know that it's going down, so our V final has to be negative 22.9 meters per second. So it rose, came to a V of 0. Here, when it passed the point where it was launched, the V is minus 17 meters per second again. There's a symmetry here. So from here to here, 17, 0, minus 17. But then we have this additional gaining of speed as it goes down. And you don't have to calculate this in pieces. The kinematics equation tells us it's going to be negative 22.9. Now that we have that done, we can find out what is the time in the air. And so we have our V0 of 17, Our A is negative 9.81. Our V final is minus 22.9. And we're looking for the time. So we can get the V is equal to V0 plus AT. And the T is going to be, if we rearrange, V minus V0 all over A. So that's going to be minus 22.9, which is the V, minus 17, so they're both negatives, all over negative 9.81. And that's going to give us 22.9. I just use pluses, divided by 9.81. And it's going to give us 4.07 seconds. 4.07 seconds in the air. Now let's go back to our tool here, and we can drag this over and find out what the time is at the ground. 4.07 seconds. Look at that. Same answer. And if we wanted to find out how high it rises, it would be just like the problem we did before, except that, it's rising from 12 meters, and we just add that on. But other than that, those are the only things to remember when you're dealing with free fall kinematics problems. Is once you've assigned a direction positive, everything that's in the opposite direction has to be negative, and sometimes you have to overrule your calculator and change the sign if that's what the problem warrants. All right, folks, that's it.